Hi, my name's Atul and I'm an online tutor in London right now.
Hi, I'm Paul and I'm a chemistry tutor based in Burnley, Lancashire right now.
Brilliant. So today we're going to talk about positive and negative charges and how that leads to electrical neutrality or an imbalance of charge, negative charges, positive charges. This is more a maths video than a chemistry one, and which can then be generalized to be used for physics and chemistry. So we'll start off with the definition of a zero pair. So what we have here on the bottom left is some counters, and the yellow counter could be thought of having a positive charge and the red one a negative charge. So if I was to move a positive charge and a negative charge together, they have a charge of 1 because it's only one counter. Mathematically, we know that 1, as in positive 1, added with both together with negative 1 gives us 0. So when you bring a yellow and a red together, you get 0. This in maths teaching is called a zero pair. So a pair, a yellow and a red is a zero pair. So I'm just gonna call that. Okay, so therefore it follows that you can have 2 yellows and 2 reds. So you could drag those to the middle as well, Paul, and we can combine 2 zero pairs.
Okay, so two positives and two negatives.
Yeah.
And yeah, there's 2 zero pairs there.
Yeah.
That's it.
Brilliant. So then mathematically we could say, well, those are 2 positives or 2 added with both together with 2 negative charges. And that again brings back to 0. Okay, so we're now going to explore these zero pairs and charge imbalances on another website, which is used for maths teaching, but can be used for chemistry as well. And it's called Mathsbot.com. So if you travel over there, Paul, we can get into more exploration on that site. Okay, so the great thing on this site is that you can see the positive and the negative there is just like it's a store. So again, if you move 2 positives and 2 negatives into the middle, and we'll see what happens. Okay, so that was 2 positives and 2 negatives. Put them together, you get a 0. So you'll get the same again if you did 3 positives and 3 negatives, and so on and so forth. So now let's explore the idea of an imbalance in charge, which we see in electrostatics in general, or electricity in general. Let's get 4 positives and 3 negatives.
Here we go. 1, 2, 3, 4 positives and 1, 2, 3 negatives.
Yeah. So this is an imbalance. I called it an imbalance, and you can zero pair. There's 3 pairs, so there's 3 pairs of red, yellow, red, yellow, red, yellow. So you can merge those and hopefully it'll disappear. So we're left with a net charge after taking all of the charges into account, an overall charge, net charge of +1. And you can do this with a whole load. So we can do another one. You can just do 5 positives and 3 negatives, for example, or maybe let's do it the other way around. 5 negatives and 3 positives.
Okay, so 1, 2, 3 positives, and 1, 2, 3, 4, 5 negatives.
Yeah. So there's going to be an additive interaction, which you can.
Okay, so we have 1, 2, 3 0 pairs, and we're left with -2.
Yeah. So we had 5 negatives, 3 positives. There's a net additive interaction, and you end up with -2. Okay, so you can clearly see that you can have an imbalance of charge. The charge doesn't have to be, negatives don't have to be electrons, and positives don't have to be protons. They could equally be any type of charge. So that could be a positively charged ion, for example, or a negatively charged ion. And we'll get into the specifics more when we discuss that in a chemistry context. Okay, great. So let's go back to Bitpaper and can explore some other things there as well.
Okay, so back to Bitpaper.
Okay, so we know that in chemistry, for the most of it, we are dealing with electrons, an imbalance of electrons. So it's not, we can't change the proton numbers as such. So it's the negative numbers that will change. So again, you could show me 3 protons and 3 electrons together. So the 3 pluses and 3 minuses.
Okay, so 1, 2, 3 pluses, and was it 3 minuses as well?
Yeah.
1, 2, 3.
Yeah. So these are 0 pairs, so I could, because we could merge these and make them disappear, etc., etc. So in chemistry, we could model these as pluses as protons and these as electrons. Let's say we added another electron to the system, so add another minus.
Yeah, so something could gain an electron, say, to gain a full outer shell.
And this therefore has an extra charge. So I'm going to draw a 0 out here. Actually, I think I found this, some of my people have found this very handy. It's not a 0 as in a 0 shape, but it's kind of like a circle. And these are all the 0 pairs on the Mathsbot site that to actually quite literally disappear. So you're left with a charge of -1. So in chemistry terms, this could have been an atom. It's got 3 protons, 3 electrons. We added an electron, and the entire ion is left with a net negative charge of -1. Okay, let's consider another situation. Let's say it's the same atom, and this time you can remove an electron. So we can't change the number of protons, but it's the number of electrons that change. So you can remove one electron here.
Yeah. So this could be, say, a metal that needs to lose an electron to gain a full outer shell. So just select one of these and remove it.
Excellent. And again, 0 pair, 0 pair. You can think of that as 0. You can even make it completely disappear. So you're left with a net. Net being a careful choice of words after taking the addition into account, charge addition of +1. So we will build upon this idea with more specific cases where we consider ions, electrons, and more of that electrostatic stuff. So so we'll be using these representations, these dots with the pluses and minuses, and that will explain how and why atoms are electrically neutral, ions are not, and which way they are and which way they're not, why they're positive or negative. Brilliant. So we'll do that in another video, and yeah, I'll catch you on that one then, Paul. All right, thanks.
Okay, thanks, Atul.
Right.
See you later.
Yeah, bye.